Hi, now we are going to do a new topic, kinematics. We are going to talk types of motion and we are going to discuss about scalars and vectors in detail. What is called a scalar product? What is called a vector product? What are the properties of it? Vectors, triangle law vectors, parallelogram law vectors, components of a vector. All in detail we are going to discuss. One by one we will see. Rest and motion. What is called rest and motion? Rest and motion are relative terms. And the second thing, it depends upon the frame of reference, how you are viewing, from where you are viewing. It is called frame of reference. In that sense, the person at rest, person moving in a bus or car or train is watching an event. So rest frame, moving frame. From where you are watching, the person, one person is at rest, one person in motion. From where you are watching. The person moving, seeing a person standing on the road. So for the person who is moving in the bus or car, another person standing at rest. So these two are relative terms. Change of position from one point to another point, change of position. That is called motion. That change of position is not occurring after a time of 3 seconds. After a set interval of time, then you can say the body is at rest. Frame of reference is a very important concept here to discuss rest and motion. Types of motion. Linear motion, circular motion, rotational motion, vibrating motion. Linear motion, you can say the body is moving. One dimension, 2 dimension, 3 dimension. Or the body can be at rest also. That is a different issue. Persons standing in a line, standing in a queue. To represent that, one dimension is enough. I am writing something on the board, something on the notebook, something on the book. That is called 2 dimension. You need x-axis and y-axis. Aeroplane is moving, bird is flying. This is all coming in 3-dimensional view. So that is called linear motion. Circular motion, the body moving in circular path with a velocity omega, that is called angular velocity. Linear motion means the velocity, we call it as linear velocity V, acceleration, linear acceleration A. Whereas in circular path, it is called angular velocity and angular acceleration. Rotational motion. The body is rotating. Earth is revolving, rotating around the sun. Earth spins on its own axis and then revolving around the sun. You should know the difference between these two. Normal movement, circular motion. Spins on its own axis and then revolving. Vibratory motion, the particle is vibrating from the mean position. Above and below, the particle is vibrating from the mean position. So, basic information, types of motion. So, one-dimensional motion, two-dimensional motion, three-dimensional motion we have discussed. So, in three-dimensional motion, what is the velocity in which the particle is moving? What is the acceleration in which it is moving? Circular path means what is the acceleration? What is the force it experiences? Everything should be counted. That now we will discuss later. Centripetal acceleration, centripetal force, that concept and all will come into the picture. That we'll discuss later. Okay. Scalars. Vectors. Physical quantities that possess only magnitude are called scalars. Physical quantities which possess magnitude and direction, we call it as vectors. Quantities which possess both magnitude and direction are called vectors. You are representing a line with the arrowhead. So, line with the arrowhead means it is a vector. Line with the arrow. This arrow represents the direction. Line represents a magnitude. So, A vector, P vector. So, direction of line with the arrow mark. Directed line segment, that we call it as directed line segment. So, this is called representation of a vector. Physical quantities which are scalars, only magnitude depends. Mass, length, time, this and all comes in scalars. Density, mass by volume, area, volume and all, it is scalar quantity. Represented by a direction, momentum, velocity, acceleration, force, all these things we call it as vector quantities because it depends on direction. Okay. Quantities which possess magnitude only scalars, magnitude and direction are called vectors. Addition of vectors. Two vectors A and B can be added. Resultant R is equal to A plus B. Addition of vectors. Subtraction of vectors. Vector A, vector B, opposite direction. So I can write A minus B. Resultant. Direction is opposite. So we are putting minus sign. Why we are putting A minus B, sir? Why not B minus A? Definitely we can put that. But in this representation of Cartesian coordinate system, this is called the origin, x-axis, y-axis. On the right-hand side, anything to be taken as positive. On the left, it should be taken as negative. So, B is pointed towards left. So minus. This is first information. Second thing, magnitude of A is more than that of B. So A minus. Opposite direction means difference only. Magnitude of A is more, so we are putting A minus. This is called subtraction of vectors. Triangle law of vectors. Generally, triangle law of vectors. In this case, suppose I have a vector A and I have another vector B. This is the representation. Addition of vector means what you have to do is vector A, end of the first vector, that is head of the first vector, tail of the second vector. Tail of the second vector. These two should be joined. Then the resultant vector will be the vector sum of A plus B. This is all. Vector A, this is vector B, R is equal to A plus B. No, sir. I want to prove commutative law. B plus A is equal to A plus B. How will you write? You can. This is vector B, you take it as first. This is vector A, you take it as next. This is resultant B plus A. You see here, resultant magnitude and direction is same in both the cases. So vector addition is commutative. Commutative means A plus B is equal to B plus A. That is called commutative. Vector addition is commutative. Okay. Resultant of triangle law of vector. Or resultant of a parallelogram. Also, what is called a parallelogram? A and B, you have taken two vectors. Parallel to A, parallel to B, you draw. This is A and B, parallel to A. This is parallel to B. This is a parallelogram. Opposite sides are equal and parallel. This is the resultant. This is the result. This we can call it as a triangle. So two triangles combined parallelogram. So resultant of a triangle you can say, or diagonal of a parallelogram you can say. How to calculate the resultant? As usual, consider two vectors A and B. Vector A, vector B. Or here also you can take vector B. Tail of the second vector and head of the first vector is joined. Straight line. This is the resultant of. So you drop a perpendicular. Take this is theta. This is the resultant of angle between A and B is theta. Angle between A and the resultant you take it as alpha. Theta is the angle between the two vectors A and B, the direction. Alpha is the angle between the resultant of the two vector and the vector A. P, Q, M, N. We name it. We need Pn. Here, PQ vector is equal to A vector. Mn vector is equal to B vector. Pn is equal to R vector. So, Pythagoras theorem from triangle NPM, Pn square is equal to Pm square plus Mn square. Pm square plus Mn square. Correct? Simple case, na? Pm is what? PQ plus QM. PQ plus QM the whole square plus Mn square. This is Pm square. PQ square plus QM square plus 2PQ QM plus Mn square. Equation 1. Now we have to calculate what is QM. We have to calculate what is Mn. For this theta, this QM is nothing but adjacent side. For this theta, this Mn is called opposite side. So calculate using the triangle NQM, sin theta and cos theta. Calculate these two, QM and Mn. Okay. From triangle NQM, sin theta is equal to, what is sin theta? Mn by Qm. Cos theta is equal to adjacent side QM. Sir, sin theta is opposite side Mn by hypotenuse. Hypotenuse is Qn. Cos theta. Adjacent side by hypotenuse. Qm by hypotenuse. So, Mn is equal to, what is Qn here? Qn is B. Qn is B vector. Qn is B vector. PQ is called A vector. Pn is R. Okay. So Mn is equal to Qn sin theta. What is Qn? B sin theta. Qn cos theta. B cos theta. So substitute the values of Mn and Qm in equation 1. You will get the answer. What answer? Therefore, Pn square. What is Pn square? R square is equal to PQ square. PQ is nothing but A square plus QM square. QM square is B square cos square theta plus 2PQ QM. 2PQ A QM B cos theta plus Mn square. Mn square is B square sin square theta. So you can take A square plus B square cos square theta plus B square sin square theta plus 2AB cos theta. A square, you can take out B square common, sin square theta plus cos square theta term will become 1 plus 2AB cos theta. I want R square root of A square plus B square plus 2AB cos theta. This is the resultant of a triangle law vector. You can put vector sign, no? Sir, resultant direction I want to calculate. How to calculate the resultant direction? Any case, if you want to calculate the direction, calculate tan theta. In our case, resultant direction. So we have to calculate tan alpha. Resultant means tan, that's all. So from triangle NPM, calculate tan alpha. Tan alpha is opposite side Mn by adjacent side Em. Opposite side Mn is what? B sin theta. Sin theta by cos theta is tan theta. So opposite side by adjacent side. So B sin theta by Pm. What is Pm? PQ plus QM. PQ is what? A plus QM is B cos theta. So the resultant tan alpha is equal to B sin theta by A plus B cos theta. B sin theta by A plus B cos theta is called tan alpha. Depending upon the value of theta, alpha value changes. What is the meaning, sir? Theta is the angle between the two vectors A and B. Depending upon the value of theta, the resultant R and tan alpha changes. How? When theta is equal to 0, when theta is equal to 90, when theta is equal to 180. So in these three cases, we have to calculate the value of R and tan alpha. What is R? R is equal to root of A square plus B square plus 2AB cos theta. Root of A square plus B square plus 2AB cos 0. Cos 0 is 1. So I can write root of A square plus B square plus 2AB. That is nothing but root of A plus B the whole square. That is nothing but A plus B. You see here, this is called vector addition. What is the meaning? Both the vectors pointing in the same direction. The resultant will be sum of the two. That's what you have written here. Then I don't have any resultant direction now, sir. Same direction only. Yes, you see here. Tan alpha is equal to B sin theta. B sin 0. Sin 0 is 0. Denominator, let it be anything. 0. So alpha is equal to 0. So the angle between the resultant and the vector A is 0 because both the vectors are pointing in the same direction. Okay. When theta is equal to 90, when you say theta is equal to 90, R is equal to root of A square plus B square plus 2AB cos 90. Cos 90 is 0. So resultant will be root of A square plus B square. This is Pythagoras theorem. A and B both are perpendicular. Resultant will be R is equal to root of A square plus B square. R is tan alpha is equal to. So R we have calculated tan alpha. B sin theta by A plus B cos theta. Theta is 90. So sin 90 is 1 by A. Cos 90 is 0. So the answer is B by A. Second case. Third one. When theta is 180, when theta is equal to 180 means we can write R is equal to root of A square plus B square plus 2AB cos 180. Cos 180 is minus 1. So I can write minus 2AB. Cos 180 minus 1. So minus 2AB I will get. That is root of A minus B the whole square. That is A minus B. This is what we saw in subtraction of vectors. Theta 180 is what, man? This is A and this is B. Opposite direction. Two vectors are in opposite direction. Opposite direction means theta is 180. Resultant will be A minus B. Tan alpha. Q sin theta, I mean B sin theta, theta is 180, sin 180 is 0, resultant is 0 because same direction, opposite direction, anything you take that is no resultant. Resultant with A only alpha, alpha 0. The most important question, this is triangle law, resultant of triangle law vectors. We have discussed the magnitude and direction and the different cases. Okay. Next. Component of a vector. Every time any vector you are representing cannot point in a straight line, exactly horizontal, exactly vertical, you will not get. See here, in the case of triangle law, angle between A and B is theta. So it is not pointing exact vertical, exact horizontal. In that case, we have to resolve that particular vector into its components. This will be very useful in many cases. First, we'll say what is component of a vector. X and Y. You are representing a vector A which makes an angle theta with the horizontal, with x-axis. Dotted line, dotted line. Along the direction of x-axis, you take it as AX. Along the y-axis, you take it as AY. P, Q, R, S. I want PQ and I want PS. You can calculate. From triangle RPQ, PQ square, PR square will be not necessary. You calculate sin theta. What is sin theta? RQ by PR. PQ is equal to AX. PS is equal to QR is equal to AY. So PQ by PR. What is PQ? AX. PR is nothing but the vector A. So AX is equal to QR or argument is AY. This is sin theta only. Sin theta is RQ. Opposite by hypotenuse. RQ. RQ is nothing but AY. Okay. So I can write RQ is nothing but AY by A. So AY is equal to AC. Calculate cos theta from this. Cos theta is equal to adjacent side by hypotenuse. What is adjacent side? PQ by hypotenuse PR. PQ is nothing but AX. PR is nothing but A. So AX is equal to A cos theta. AY is equal to A sin theta, AX is equal to A cos theta. So this is the representation, resolution of a vector. So along the x-axis, the vector A can be represented by A vector cos theta, and along y-axis it is A vector sin theta. Here you might have one doubt. What doubt? Sir, simply A only I have got. Now I am getting A cos theta, A sin theta. My original value should not be disturbed. It is A only. By the resolution of a vector, the originality is not disturbed. How? You use Pythagoras theorem here. PR square is equal to PQ square plus QR square. PR square is nothing but A square. PQ square, what is PQ? AX square plus AY square. AX square is what, ma? A cos theta the whole square. A square cos square theta plus AY square. A square sin square theta. Take A square outside. Sin square theta plus cos square theta is 1. Left hand that is also A square, right hand that is also A square. Your value is not changing. Same value is not changing. Okay, so this is resolution of a vector. In the case of projectile motion, when a body projected at an angle, when a simple pendulum bob is oscillating, the weight mg can be resolved into two components. Cyclist while moving in a curve, the weight mg, the normal reaction r can be resolved into two components. So resolution of vector, this is called resolution. Otherwise, component of a vector, otherwise known as resolution of a vector. Okay, fine.